Okay, today we're going to look at some word problems using sequences and series. We're going to look at a few more sequences and series problems, and then we're going to look at sigma notation. Please pause the video and check last night's homework. Alright, here we go. Number one, word problem number one. We have three word problems. Suppose a movie theater has 42 rows of seats, and there are 29 rows in the 29 seats in the first row. How many seats are there in the theater? The first thing we have to notice is what kind of sequence this is. Well, if there are 42 rows of seats and 29 in the first row, and each row has two more seats after that, then obviously this is going to be an arithmetic sequence. How many seats are there in the theater is telling us to find S sub 42 because there are 42 rows. So I need the first term, which I have. I need the 42nd term, which I don't have. So I'm going to say 29 plus n minus 1, so that would be 41 times d, which is 2. Grab my calculator. And there are 111 seats in the 42nd row. So S sub 42 would be 42 times 29 plus 111 over 2. Grab my calculator. And that gives me 2,940 seats. Alright, so this is a similar problem. Why don't you pause the video and try this one on your own. Okay. This is a similar problem. It's another arithmetic sequence. Now we have 25, and then each row has one more, so that's our common difference. So our rule for the number of seats in the nth row would just be 25 plus n minus 1 times 1. 35 students want to sit in the same row. How close to the front can they sit? Well, 35 is the nth term. So we're going to say 35 equals 25 plus n minus 1 times 1. Well, we know that this is really just n minus 1. And then this would just be 35 equals 25. And then 25 minus 1 would be 24. Subtract 24 from both sides, and we find out that they should be in row 11. What is the total number of seats in the concert hall? So we are looking for S of 32. Again, if you need time to try this on your own, please pause the video. The first thing we need is the 32nd term. So that's going to be 25 plus 32 minus 1, which is 31, times 1, so that's going to give me 56 in the 32nd row. So it's going to be 32 times 25 plus 56 over 2. So that's going to be 1,296 seats. Okay, number 3. A certain substance decomposes and loses 20% of its weight each hour. If the original quantity of the substance is 300 grams, how much remains after 7 hours? Well, you can see we know the first term, we know the 7th term. Is this arithmetic or geometric? If we are losing a certain percentage each time, this is almost like an exponential decay formula. An exponential decay formula would follow a geometric pattern because we are multiplying. So think about it. If we are going to lose 20%, that's like 100% minus 20% means 80% remains. So to find the 7th term, we're going to start with 300 times 0.80 raised to the 7 minus 1, which is 6. And that's going to give me 78.5 0.6432 grams. Again, we know it's exponential decay because it says loses. If it gained 20%, this would say 1.2. Alright, let's take a look at a couple additional problems. Why don't you pause the video for 5 minutes and try to work on these on your own, unless you're totally stuck, and then we can work through them together. Find the sum of the first 10 terms of the geometric series, then find n such that S of n is this big number. So the first 10 terms would be the first term, and then 1 minus, well, it's going to be negative 3 to the 10th over 1 minus negative 3. So I'm going to grab my calculator. And I got negative 14,762. Alright, now, what I'm going to do here is I'm going to write an equation for S of n. I don't know why this is like all wiggly sometimes today. 1 minus negative 3 to the n, and then 1 minus negative 3. And I know that this is 4. What I'm going to do in y equals, I'm going to put 1 minus negative 3 to the x power. I want you to notice I'm not making this positive. That would invalidate the order of operations, which says I have to do the exponents first before I can subtract. So everyone take a moment and plug that into y equals on your calculator. Okay, once you have that into your calculator, go and look at your table and scroll down until you see 838,861. Now I want you to realize that I've done this problem completely wrong, which some of you probably are going, Ms. Strauss, what's wrong with you today? And my answer would be, I'm really tired. This should be a 4, not a 3. Maybe I was thinking ahead about the 4. Wow. I'm not recording this whole video again. We can just fix it. Thanks to those of you that are going, she's doing this wrong, she's doing this wrong, she's doing this wrong. Alright, so the answer here should be negative 209,715. So then here, negative 4, negative 4, negative 4. This makes this a 5. Go to y equals and just fix that. I knew I had a mistake because nothing on my table showed up. So now when I look at my table, I see at x equals 11, I get this sum. So it has to be n equals 11. Sorry about that error. Two terms in a geometric sequence are a2 and a5. Write a rule for the nth term. Well, this is geometric, so 1, 2, 3, 4, 5. This is 28, and this is negative 2. So to get from 28 to negative 224, we went 1, 2, 3 spaces. So we did 28 times ratio times ratio times ratio. So I'm going to solve for my ratio by dividing negative 224 by 28, and I get negative 8. Well, that's handy because now I know my ratio. Where's my pen? Pen! There it goes. This pen craps out on me. We're in trouble. And we're in trouble. So we have r equals negative 2. Write a rule for the nth term. So we're going to have a sub n equals, so we need the first term. So let's think. 28, if the pattern is multiplied by -2, if we divide by -2, that would give us a first term of -14 to the n minus 1 power. Okay. Okay, I have 2 dead pens right now, so I'm going to do the best I can just typing it out and using the mouse, so bear with me. Number 3, if S of n is 93, we have a first term of 3 and a ratio of 2, find n. So we know there's a ratio of 2, so the first thing I'm going to do is say, okay, if S sub n, that has to be 3, and then 1 minus r, which is 2, to the n power, divided by, and then 1 minus, you know what? Let's do it like this. Divided by, let's see, we've got 1 minus r, so 1 minus 2 would be -1. And again, guys, all I'm going to do is I'm going to put that in my calculator exactly as it looks, except I'm going to put in x for n. So 3 times 1 minus 2 to the x, all divided by -1. And I'm going to go to my table, and I'm going to look for 93. And awesome, it's at x equals 5, so that means n equals 5. All right. 2 terms of an arithmetic sequence are a4 equals 7 and a15 equals 40. Find a rule for the nth term. Then find a value for n for which the nth term is 25. The first thing I want to realize is to get from 7 to 14, I would have to take 7, tired of pink, let's go to red. I would have to take 7 and add to that 11 common differences, because I would have to add 11 times to get from the 4th term to the 15th term. So I'm going to set up the equation, 7 plus 11d equals 40. And then I'm just going to solve for d. So 40 minus 7 would be 33, and then 33 divided by 11 would be d equals 3. Alright, so now my rule for the nth term is going to be a sub n equals the first term. Now I don't know the first term, so I'm going to grab my calculator. The 4th term is 7, so then I'm going to subtract 3. That would give me 4 for the 3rd. Subtract 3 again. That would give me 1 for the 2nd. And then subtract 3 again, and that's going to give me -2. So I've got -2 plus n minus 1 times 3. And honestly, guys, now all we're going to do is say the 25 equals this. And we're going to solve. So everyone pause the video and solve for n. You should get n equals 10. Number 5, find the sum of the first 30 terms of the arithmetic sequence. Then find n such that the sum is 2,485. So immediately I need to find the 30th term. So a sub 30 is going to equal the first term plus n minus 1 is going to be 29 times 4 is our common difference. So 3 plus 29 times 4 is, and now the sum of 30 terms would be 30, and then we've got 3 plus 119 divided by 2. Again, my handy dandy calculator gives me 1,830. Find S of n such that S of n equals 85. All right, so what I'm going to do is I'm going to write my equation for S of n. Now, this is an arithmetic sequence. The problem is, unlike geometric, I don't just have n as my variable. So what I'm going to have to do over here, so like here, right there. So I'll put a little arrow there. Oh, there's the arrows right there. We are going to need an equation for that. So we're going to have n, and then we know the first term is 3, plus now we're going to have to put the formula in for the nth term. So I'm going to switch to blue to put my formula in for the nth term. So my formula for the nth term is the first term plus n minus 1, which is my variable, times d, which is 4. So that's the formula for the nth term. And it's in the place of the 119 that was above. So divided by 2. Ladies and gentlemen, what we're going to do is we're just going to take this, which is our formula for... Can I make just that yellow? No. Oh, snap. Take that off. And we're going to put this that I currently have highlighted into y equals. I don't know how many terms, so I'm going to put in x parentheses, 3 plus, and then my formula for the nth term in parentheses. And I'm going to, once again, just look on my table for, I think I'm missing a close. I am missing a close. That one should be blue. I'm going to just look on my table to see what n is, to see what n value gives me that amount. I got to do some scrolling. Oh! Uh-oh, I think I mistyped something. It's not there. Yeah, I forgot to divide it by 2. So I put that in. Now I look for 4,000. Oh, there it is. At 35 terms, I have that sum. All right, let's talk about sigma notation really quickly because honestly, this typing is a drag. Sigma notation is not going to be as bad as it seems. If it says find the sum of the series, all we need to do is write out the series using the formula. I want you to take a look. What's here, that's going to be the first n value. Okay? Up here, that's our last n value. And then right here, we have our formula terms. All right, so you can see that the formula here was 2i. Our first n was 1, our last was 6. So 2 times 1, 2 times 2, 2 times 3, all the way up. And then the sigma means sum of all these terms. Here, the first n value was 3. The last n value is 6. So we've got 3, 4, 5, and 6 being replaced into the formula, and then we just add them all up. There's no magic that goes on here. It's just plain old arithmetic. So let's just do one together. Find the sum of the series. So literally, this is actually not so bad to type. I start with 5, and I've got 5 squared plus 1. And then I've got 6 squared plus 1, and so on. So 5 squared plus 1 would be 25 plus 1 is 26, plus 6 squared plus 1, 36 plus 1 is 37, 7 squared plus 1, 49 plus 1 is 50, 8 squared plus 1, 9 squared plus 1, 10 squared plus 1. Grab my calculator. I know some of you are so excited that I say that, like Shirvani. He's excited. And I got 361. I hope that's right. All right. Ladies and gentlemen. Whoop, there it is, 361. Go us. What I want you to do right now is I want you to just practice this for a couple minutes. So take a look at these, maybe just work on, compromise. How about just these three, 44, 48, and 52. Pause the video for like 3 minutes and work on those three, and I'll reveal the answers. Alright, I'm going to unpause them. I'm going to clear them, so if you're not done yet, pause. Alright, here are our answers. What I want you to do right now is get started on the homework, worksheets 11.1a, 11.2a, and 11.3a. Please remember we have a quiz coming up on Thursday. Have a good day, guys. I'll turn the page so you can check your answers. Here's 11.1. The other ones are on the next page, and I will put this lovely flip chart on Edline for you.